Hello, everyone. We meet again. I'm Jackie, and I'm here to talk about the most missed questions from the June 2025 SAT exam. So let's get to it. Okay, so as I predicted in my June predictions, I did feel like functions would be definitely occurring on the exam. And here's an example of one that came up. So as you can see, here it says the function f is defined by f of x is equal to negative x cubed minus ax squared minus bx minus c, where a, b, and c are integer constants. The zeros of the function are -9, -4, and 5. What is the value of a plus b? So for this one, to solve super quickly, I would definitely put it onto Desmos, and I will show you how to do that. But for those who are curious and want to see the whole math work through and the full-on algebra, I will show that after the Desmos. Okay, so let's take a look. Okay, so we have question on the left and Desmos here. So first, what I'm going to do is put table in. And remember, you can always go to the plus sign here and put table as well. And then it tells me that the zeros are at -9. So that will be when y is equal to 0. So I'm going to, oops, type that in here. Let's go ahead and do that. 0, -4, 0, and 5, 0. Okay, so next what I want to do is type in this equation. However, I'm going to be solving for unknown parameters in this data, so I'm not going to put the equal sign. I'm going to want to put the tilde. So whenever you have a regression model, you want to put that. So I'm going to put y1, and I'm doing that because I want it to grab from the table here where it says y1. And then I'm going to put the tilde. So here to find that, you go here and oh my goodness, it's right here. Okay. And then next I'm going to type in the function as I see it here, except instead of putting x cubed, I'm going to put x1 cubed. Why? Because again, I want it to grab the information from the table. And same here, I'm going to put minus ax1, oops, sorry, ah, ax1 and squared. And then we have minus bx1 and then minus c. And look what happens. It gives me all the information I need. I have that a is equal to 8, b is equal to -29, c is equal to -180 if I needed that. And you see here it says that the RMSE is equal to 0. Well, you can, oops, click here to learn what it is, but I can just tell you that when it's equal to 0, it's basically confirming that everything is fitting perfectly into my regression model. So it's basically accurately solving for A, B, and C. Wasn't that so cool and fast? So to show that here on my screen, remember we have A equals 8, B equals -29. And it asked me for the value of a plus b, so I just have to do -29 plus 8, which is going to be equal to, correct answer, -21. Wasn't that so amazing using Desmos? Okay, so let's just see how we could solve that now if I didn't know how to use Desmos or something happened, or if you just want to, see the algebra work out. So again, like we know these are the zeros of the function, but if I were to display that graphically, it would be like f of x is equal to negative, because I have the negative in front here, x plus 9, x plus 4, and x minus 5. Why? Because remember, x plus 9 equals 0, x equals -9, and so on. Those will give me the zeros of the function. Okay. Amazing. But next I would want to multiply them out. So I'll show it handwritten here, but you could also type this on into Desmos as well. But for those of you who want to see it by hand, so first to do this, what I would do is just take the x plus 9 and x plus 4, go ahead and expand that. This expands to x squared plus 13x plus 36. And next what I want to do is multiply by the x minus 5. And then multiplying each term by x minus 5 is going to give me, so I have x cubed plus 13x squared minus 65x plus 36x, and 36 times 5 minus 180. Amazing. And then putting everything together, I would have x cubed plus 8x squared minus 29x minus 180. And that would be the almost final step, but don't forget that I have to apply the negative sign now to everything. So take this, apply the negative, so that our final equation of f of x would be equal to negative x cubed minus 8x squared plus 29x plus 180. And then you can see, looking here at the values, that this correlates to this. I can see that the negative a is equal to negative 8. So a would be equal to positive 8, which is what we saw there on the graph. And negative b is equal to the coefficient in front of x, which is positive 29. And that gives me that b is equal to negative 29. So we get the same answer. And that's it. The answer is negative 21. Wasn't that a good one? Okay, so I hope that made sense and you thought that my use of Desmos was amazing. But let's just take a look at another one so you can get extra practice in case it shows up on, a future exam. Okay, so let's take a look at this one. So you see here, we have g of x is equal to x cubed plus ax squared plus bx plus c. The function g has zeros at -2, -7, and 6. What is the value of a? So here I'm only asked for the value of a, but same exact concept. Why don't you pause the video, solve this, and see if you get the answer, and we'll double check after you unhit the pause button. Okay, so same exact thing that I did in the previous one. I'm going to put on Desmos, type in my table, and put in the function has zeros. So this would be -2, 0, -7, 0, and 6, 0. And now all I'm going to do is type in the function, and I'm going to put g of x, so y1 is, remember, you don't want to put the equal sign. We're going to put the tilde, which we can find here, do dt, and then I'm going to type in. So we have x1 cubed plus a x1 squared. And remember what I'm doing. I'm taking the 1 here because I want to grab these coordinates from the table. Plus b x1 and then plus c. And we can see, just like the previous one, I have everything here at 0, meaning it fits the regression perfectly. And I see that a is equal to +3, c is equal to -84, b is equal to -40. So the correct answer would be 3. Wasn't it so good and so amazing? I'm just trying to switch my screen back. Okay, so here it would be 3. Okay, so this is an amazing function. Amazing way to solve it is to use our handy dandy Desmos calculator. And next, let's see what's on the docket that I think you should next know. Okay, so this one was actually a very similar one I put on the predictions video in the functions, must know functions that you should know. And this one, well, similar questions to this have appeared multiple times historically on the SAT, even when it was paper-based. Yes, guys, I've taken the SAT since it was paper-based. Oh my goodness. So I'm going to show really quickly how you could determine this with no Desmos calculator, but then I'm also going to show on Desmos. Actually, reverse. I'm going to show you on Desmos first, and then we'll look at it algebraically. Okay, so this one, let me switch on over to Desmos. Okay, so here we go. Um, do dee dee dee, do dee 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 dee. Oh, here we are. We meet again. So we see, oh, my amazing question. So again, I want to know how to type in the table. So here it tells me that f of 32 is greater than 0. So this is my x input. So I can type in 32 here. And it gives me a y output that must be greater than 0. I'm just going to type in like 2. Here it says f of 35, so my x input is less than 0, so I'm going to make that -1. You can really choose multiple values. I will show that y at the end. And here it says f of 38 is greater than 0. So we can just make this like, let's make it 4. Okay, so then again, just like you've seen me do it, I'm typing in the parameters. I don't know precisely what they are, so I'm going to put the tilde in again when I'm typing. So what I'm going to do, y1, so it grabs from my table. Then I go ahead and I put in the tilde symbol. And then I'm going to do what the function tells me, which was x, but x1 minus a multiplied by x1 minus b. Okay, so here I can have some approximations for the A and the B. And here, since I'm going to want to round the values of A plus B to see what that gives me. So here it gives me 70, which isn't an answer choice. So probably I would just play around with that a little bit more and be like, okay, let's make this 3. This is 7. Look, it works out. If you take this down, like this is to 1 again, and like make this also 1, you can see it gives me 70, but you can keep playing around. 3, 4, 5, look, 5, 6, 7, 8, 9, and so on. So you see that it's between 68, 69, and 70. And 69 would be our winning answer here. So that kind of helps to, give me a little visual plot of what is happening. So let's take a look at um, how this could work algebraically, which I also showed on the functions video. Okay, so going back through here. So here, like I can see that this is clearly a parabola. So imagine if I were to plot this. And I know that f of 32, so we're going to say this is 32, it's greater than 0, so something like here. F of 35, it's less than 0, so maybe something down here. And then we have f of 38 up here. So I can see that the values of the x-intercepts, which are what a and b are equal to, are going to fall somewhere in between here. So I can see that the range falls between like 33, 34 approximately. And for B, that would fall between like 37 and 36. And knowing that these are the two values, if I add those together, for example, it gives me what we were seeing previously, like 33 plus 37, that's possible. That gives me 70. Which isn't an answer choice, but if I do 33 plus 36, that gives me 69. And note it says could be, which is why there's multiple possibilities here, but the one that works, it's 69. So this is to give you like a little visual representation of what it looks like. And um, well, a visual representation, but you could also see it on Desmos. I didn't really uh, show that. But here back to like our parameters, the range here of me picking the coordinates, we can see this is the parabola more or less, and it falls like within these points. Okay. So, and you, I mean, I could have made the points better and more symmetrical since it's a parabola, but I just wanted to really show that you type in any number that's greater than zero, play around with it, less than zero, greater than zero, and it will give you an output of either 69, 68, or 70. Isn't that so cool and so amazing? Okay, and again, I would know this function. It has appeared, similar ones have appeared on multiple SAT exams. More questions that have come up. This one also seems to have come up on the exam, and this is another great one that I would also use Desmos on. So it just tells me there's a quadratic relationship, and let's go to Desmos. So just erasing our previous question. Okay, so it says the variables x and y have a quadratic relationship. So I would just type in the table. It tells me x is 0, y is 60, x is 2, y is 64. And when x is 10, y is equal to 0. Which equation represents this relationship? Very simply, I don't want linear, I want a quadratic regression. This gives me negative x squared plus 4x plus 60, and that correlates to option C. Okay, so you see there's so many questions you can use Desmos to your advantage and properly solve. Okay. Okay, and next up we have yet another function. So here I have the exponential function f is defined by f of x is equal to a b to the x power, where a and b are positive constants. If f of s is equal to t and f of s plus 1 is equal to t minus 0.87t, where s and t are constants, was the value of b. So again, just special note that I did make similar predictions in my June predictions math video. But anyways, this one can be solved algebraically or also on Desmos. So first I'm going to do algebraically. And then we'll take a look at Desmos. Okay, so what this is saying, so I have the function output f of s is equal to t. And we also have that f of x is equal to abx. So to put that in as a function, this would be that abs would be my x value is equal to t, the output, in this case f of x or y. And then I also have another pair of coordinates. So this would be dt f of s plus 1. And that's gives me the output of t minus 0.87t, but this is basically 1t minus 0.87t, so that simplifies to 0.13t. And then typing that into the function, that would be the same as ab. S plus 1 is equal to our y output, which is 0.13t. Okay, so then from here, I have two equations, so I can like substitute, do elimination, but I have exponents. And whenever I have exponents, I always train my students that when you have plus one, think about, you want to reverse engineer, think about what happened before. So addition is indicative of, yes, multiplication. So this would be, well, another way I could write this is that this is AB to the S power. This is an S, not a 5, and this is B to the first power. Why is that? Because this here, it would be B S plus 1, which is exactly what I had up here before. Isn't that amazing? Okay, and that's equal to 0.13t. And then, oh look, here I have that ABS is equal to t. So now I can substitute that in here. So I'm going to substitute in the t. Then I have TB1 is equal to 0.13t. And then divide each side by t. Cross out, cross out. And I get that b is equal to 0.13, which would be the correct answer um, option A, because I'm asked for the value of B. Okay, so amazing. But I do have a lot of students who are like, but how could I solve this on Desmos? Well, you've asked the right person because I know how. So let's see. So desktop. Okay, so here again, just like we've been doing, I type in table and then I'm going to put in my values. So here I have S, Y value is T, and then the second coordinate of X is S plus one. And here I could put in, I'll just write it as I see it. So 0.87 T, it will do the work for you. So now I have to determine what S and T are, but I'm just doing this as an example. Like I'm trying to find a module that will fit these coordinates. So just as a standard, I'm going to put S equals to 5. Doesn't matter, like we can put any range in and we'll still get the same answer. And I'm going to do the same for T. And just to show you that I can put it as anything, I'll put like T at 10. And let's make the range like -10 to 10. Okay, so next I need to graph the function given. And again, since I am doing a regression model, trying to find and fit the parameters, I don't have definite ones. I'm going to use the tilde once again, which we can find here. And then our formula, it's AB. And then here I want to pull from the X coordinates from the table. So you can see that's why I'm putting the X one, so it pulls these. And oh my goodness, look, that's exactly what I solved for previously, which was 0.13. And wasn't that amazing? You can see like I could have put S value to anything and it doesn't change. B is going to stay consistent at 0.13. Wasn't that so cool and so amazing? Okay, so a lot of useful tricks here to use Desmos properly. Okay, so guys, these were difficult questions that appeared on June 2025 SET exam. So stick around. I'll be posting more content for upcoming SET exams. Like, rate, subscribe if you like this video. Share with your friends if you found it useful, because the more people we reach, the better we make the world. Okay, so thanks for watching, and I will see you in the next video. Bye, guys.